So what you're given here is what they call a tree diagram. A tree diagram. And a tree diagram is useful when there are multiple events occurring after another. So we have one event in which you have either board game or a card game. And then the next event is going to be on Tuesday. And then you would have to calculate the probability of getting another board game or card game. And then if you played card game the previous day, you can either choose one of the two, board game or card game. So in this case, we need to figure out, for number 4, probabilities for 2 of the 8 outcomes are shown. Calculate the approximate probabilities for the remaining 6 outcomes. All right, so for the remaining 6 outcomes, what we have to do is we have to multiply 7500s times 7500s times 7500s will give you B, B, B. And so 7500s times 7500s times 7500s gives you 421,875 millionths. Kind of a lot to say there, so I'm just going to say 0.421875. Now, what would I have to do for BBC? I have to calculate 0 and 7500s, because that's the first B. That's right there. The second B is the same amount of probability, 0 and 7500s, which is the same as saying 75%. And then C, in this case, C is 2500s. So if I multiply 75 times 75 times 25, all of them hundreds, I'm going to get my answer. And since you have a calculator, I'll let you do that. Okay, now let's go over for B. B is 7500s times C, 0 and 2500s times another 7500s. So you notice we're going to multiply by the same numbers here. Do we need a calculator? Probably, but if you already figured out this one, you figured out this one already because it's just one of these numbers switched, which is called the commutative property. So it's just 3 numbers being multiplied, and it doesn't matter which order. Now we have B, C, C. B, C, C. So first I start with B, again 7500s, times C, 2500s, times another C, 2500s. And so I will multiply this. You know what? Already I can see from below, 2500s times 7500s times 2500s. The order does not matter when I multiply because it's called the commutative property. So I know my answer for this one already, 0 and 46,875 millionths. All right, well, that's awesome. That's easy. So now I just keep on going. Now I have C. I start with C, so I'm going to multiply 0 and 2500s times the probability of playing a board game times another probability of playing another board game. 2500s times 7500s times 7500s. Wait a minute. Did we multiply those 3 exact same numbers before? Here and here. Yes, the order does not matter. It's commutative property. So whatever we got there, we will get the same answer here. Again, 2500s. Where did I get that 2500s? Because I'm playing a card game for my first one, and I'm playing another card game for my second one. So it's another 2500s times B, which is 75% of the chance, or per time, which is 7500s. And now I will multiply those, and I have 25 times 25 times 7500s. Wait a minute. Are you telling me that this number and that this number here are the same? Oh, well, we already multiplied those 3 exact numbers. And so using commutative property, we know that this will be the same thing. C, C, C. Yes, yes, yes. Okay, now we have 2500s times 2500s times 2500s. They're all C's. And so you'll multiply those 3 to get your new number. Okay, And so that is what 4 is asking. And you have a calculator, so I'm going to say use calculator. What is the probability that there will be exactly 2 nights of board games over the 3 nights? Well, I'm going to clear this up so I can figure this out. So I need exactly 2, 4, 6, 8, 7, 5. 2 nights of board games. So I only need 1 card game. So I'm going to highlight the ones that I'm talking about for number 5. They're exactly 2. Exactly 2 of what board games? Exactly 2 board games. Exactly 2 board games. Exactly 2 board games. Boom. That's it. So what I'm going to do now is if I have 2 exactly board games, I'm going to add up whatever I got for my probability there, whatever I got for my probability there, and whatever I got for my probability there. I'm going to add those amounts, and that will give me my final probability of exactly 2 nights of board games over the 3 nights, Monday, Tuesday, and Wednesday. Last one. What is the probability that the family will play at least 1 night of card game? Let's think about this one. 1 night of card game. Let's change the color to pink. At least 1 night of card games? Wait a minute. 1 night of card games means at least 1. At least 1 means I can have 1 card game. So, okay, that's 1 card game. That's 1 card game at least. I have 2 of them here, so that's at least 1. That's 1. This is 2. This is 2 card games, so it's at least 1. This one's 3. Whoa. So all of them, except for the first one here, I have no card games. So I want you to understand this. When you are talking about all of the outcomes, that is 1 whole. And other instances, we said 100% is the whole. 100% is equal to 1. So with a probability of 1, that means you have all things occurring for sure. We have 1, 2, 3, 4, 5, 6, 7 of the things occurring, and the 8th one is missing. So we're going to actually find the difference between 1 and whatever decimal number that is, 0.421875, will give me the remainder of what's going to happen as a probability of having at least 1 night of card games. So 1 minus 421,875 millionths will give you a number that is a little bit over 500,000 millionths. I don't know these numbers, so you're going to have to figure that using a what? Calculator. And then you'll know that if you were to play board games 3 nights in a row, that's going to be a pretty hefty probability. That's going to be pretty high. It's going to be over half the time. Okay, I hope that answers your questions. Goodbye.